The very first term that we come to is the term monomial. A monomial is an expression that is a number, a variable, or a product, meaning multiplication, of a number and one or more variables. And then they give you some examples. 12, just the number 12, that is a monomial. Y, just a variable by itself, monomial. Negative 5x squared y, also a monomial. If you look at this one, c over 3, that does not look like a product when you first look at it. It actually looks like division, but you can write this 1c over 3 or 1/3 c, which is a number times a variable. So it tells you this. The fraction c over 3 is a monomial, but you'll notice what they point out is not a monomial is c over x. If you have a number in the denominator, you have a monomial. But if you have an x or a variable in the monomial, it is not a monomial. So if you have a c over x or x in the denominator, rather, it is not a monomial. The x has to be in the numerator position for it to be a monomial. So let's talk about on the next page, degree. So the very top of page 457, the term degree. The degree of a monomial is the sum of the exponents of the variables. For a constant other than 0, the degree is 0. So think of it, if you have constant, that means a number. The number 3, the degree of that would be 0 because anything to the 0 power is 1. So 3x to the 0 would just be 3. So what they're telling you there is if you have a constant, your degree is 0. But if you have variables, you will add the exponents of the variables in the monomial. So let's look at the first example. Find the degree of each monomial. And so a is 2/3 x. So we are going to look at the degree based on the exponent. What's the exponent on the x? When I don't see it, it's just a 1. So my degree here would be 1. For the second one, I have two variables. I have x squared and y cubed. My degree for this one would be 5. So for degree, this has nothing to do with multiplication. This is just finding degree. Your degree is 5 here. And then the last one is a constant. And that was the definition we just looked at. A constant always has a degree of 0. All right, and so looking at these three, you literally are just naming what the exponent is when you add all the exponents together of your variables. This is for a monomial. When we do polynomials, multiple ones, then it's a little bit different. Critical thinking, what is the degree of 9x to the 0? Well, it'd be the same thing as the degree of 9. Your degree there would be 0. All right, let's look at naming them. So a polynomial, so poly meaning many, is a monomial or the sum or difference of two or more monomials. So polynomial is just a term used when you put several monomials together by addition or subtraction. And they have given you this example here, 3x to the 4th plus 5x squared minus 7x plus 1. Each individual monomial has its own degree. 3x to the 4th has a degree of 4. 5x squared has a degree of 2. 7x degree of 1. And 1 has a degree of 0. This is called standard form. Standard form of a polynomial means that the degrees of its monomial terms decrease from left to right. So you'll see each one of them has a degree and they decrease. They went from left to right, highest to lowest, and that is standard form. That's how you need to start putting your answers in standard form. Now, when we talk about the degree then of a polynomial, the degree of a polynomial is going to be the highest degree for any one monomial. So for this particular one, the degree that they gave us in the example, we are going to use the highest one, which is 4. So the degree of that polynomial is 4. For polynomials, you do not add them all together. You just use the highest one, and that is the degree of the entire polynomial. All right? They've given us some names of polynomials. The first one is a degree of 1. So they have a chart here in the middle of this page. Degree of 1 is linear. It's called linear because y equals mx plus b forms a line. It's a linear equation. And so when you have a degree of 1, it's a linear. So degree and number of terms are two different things. Degree tells you what your highest exponent is. The number of terms is how many you have added together. And so the common ones that you are going to use are binomial, trinomial, and monomial. So you'll see that over and over. Monomial meaning they have one term. Binomial meaning they have two, like bicycle. Trinomial, tri, meaning three. And so those are your common ones there, monomial, binomial, and trinomial. That's based on how many terms you have. This one has two terms, it's a binomial. Three terms, trinomial. One term, monomial. All right? And then degree is completely separate. That's based on your highest exponent. All right? Questions on just the terminology. All right? You need to know the terminology because there will be times when I say, give me the degree, and you need to know what that means and how to give me the answer there. All right? Let's look at classifying. So the first thing they want us to do is they want us to write it in standard form, and then they want us to name it based on the degree and the number of terms. So standard form, that means highest degree to lowest. The degree of this 5 is a 0. The degree of this negative 2x is a 1. So if I wanted this in standard form, I would write negative 2x plus 5. All right? Then the degree. So my degree here would be the highest one. Well, the highest one was 1. My number of terms. I have 2 terms. So this would be a binomial. Let's look at the next one. When you have, so here I have a degree of 4, a degree of 0, 2, and 4. Something else with standard form is you have to combine all your like terms, okay? So I have like terms. What are my like terms here? 3x to the 4th and 5x to the 4th. And so I want to combine those first. And I'm going to have 8x to the 4th. Standard form, I'm going to go highest to lowest. So then that would go to the 2, right? Degree of 2. So plus 2x squared. And then I would go to my degree of 0. This would be standard form. My degree for this one would be the highest one. The highest one was 4. And then my terms, I have 3 terms. So that would be a trinomial. All right, questions on standard form and naming them. So go ahead and try those 3. Put them in standard form and then name them based on degree and number of terms. So, adding polynomials. When you're adding polynomials, you are literally just looking for like terms and combining them, all right? They show 2 methods. The first method they show is to line them up vertically. Some people like that, and so you can take the trinomials, in this case, individually and line them up. You do need to make sure when you do it this way that if you're missing terms that you don't accidentally add the wrong things. And so the first method that they have is just lining these up and adding down. When you do this, make sure you line up like terms. So for example, if the second one did not have that negative 9x, you would want to make sure that you put the x squared under the 4x squared and the 1 under the 7, because you don't want to accidentally add the wrong things. So lining them vertically is fine. You end up with 6x squared, a positive 6, and a negative 9, and then a 7 and a 1. Your final answer needs to be in standard form, meaning highest to lowest. The other way to do this is just to maybe mark through or note your like terms. And so when I add these, I'll very often just go to my highest exponent in the starting one, 4x squared being my highest exponent, plus 2x squared. And so you can add them across as well, and you will get, of course, the same answer. Like term plus a like term. Make sure when you do it this way that you include the sign that's in front of it. And again, same thing for the like terms here. Positive 7 plus positive 1. So either way, whether you add them down or add them across, you'll get the same answer. If you do vertically, make sure you line up the right ones. If you do across, make sure you make a note as to which ones you have added. Because again, if you were missing a term, you want to make sure you still include it, So go ahead and try check understanding all 4 of those, A, B, C, and D. You can do whichever method, whether you want to line them up or whether you just want to add across. We have 2x cubed plus 5x squared minus 3x minus x cubed minus 8x squared plus 11. And so if you do the vertical method here, you need to be careful that when you set this up, you line these up correctly. So when you do the vertical method, you have an x cubed and you have an x squared in your second one, but you do not have just an x. You have this 11, all right? And so you have to be careful because you basically have, when you do this, you have to think of it like a plus 0 and then a plus 0x, right, when you do this vertical method. So you have to be really careful with this particular method, and you have to also remember that you are subtracting. So you're going to say 2x cubed minus 1x cubed and get 1x cubed. You have 5x squared minus a negative 8x squared. And so that is the same thing as plus a positive. So for the second one, you'll actually end up with positive 13x squared. Negative 3 minus 0, 0 minus 11. And so with vertical, you have to be really, really careful with your positives and negatives. The other method here is to do a cross like we did with addition. When you do a cross, I would actually recommend changing it to adding the opposite of everything. Because remember when we talked about addition way at the beginning of the year, subtraction and addition? Subtraction is just adding the opposite. And so you can actually change this to addition. And then you need to change every single sign inside your second parentheses. So this was a positive x cubed, make it a negative x cubed. This was a negative 8x squared, make it a positive 8x squared. This was a positive 11, make it a negative 11. And then you can just add your like terms like we did before. So you can say I have 2x cubed and a negative 1x cubed. So that will give me a positive 1x cubed. I have a positive 5x squared and a positive 8x squared. So that will give me my 13x squared. For my negative 3x, and I have nothing to combine it to. So that's just going to stay a negative 3x. And then I have a negative 11 with nothing to combine it to, and that is going to stay a negative 11. And so either way, you get the same exact answer. Just be really careful with your positives and negatives. Like I would almost change all of them to adding the opposite when you do this so that you don't confuse your positives and negatives. So go ahead and try check understanding 4. And then we're going to do some multiplication.